In this video, we're going to look at the two free response questions from our Unit 6 test review. In this first free response question, we've got a graph here. Notice it's labeled that this is the graph of f prime. And the question says, let f be a function defined on the closed interval -3 less than or equal to x less than or equal to 4 with f of 0 equal to 3. The graph of f prime, the derivative of f, consists of one line segment and a semicircle as shown above. And that's the graph that we're looking at right here, graph of f prime. Our first question says, on what intervals, if any, is f increasing? Justify your answer. F increasing, that's one of our flashcards. And what that means, if f is increasing, that means that f prime is greater than 0, or f prime is positive. And so I go and look at my graph of f prime, and the only place where this graph is positive is right here on this interval -3 to -2. And so that's going to be the answer to our question. F is increasing on the interval -3 to -2. And we do need to justify our answer, but if you've annotated the question, you've already got your justification there, because f prime is greater than 0 on that interval. All right, next question. Part B asks us to find the x-coordinate of each point of inflection on the graph of f on the open interval -3 less than x less than 4, and we need to justify our answer. So the key words there in that question, point of inflection. That's a flashcard for us, point of inflection. And a point of inflection happens when the second derivative equals 0 and has a sign change. But I am looking at the first derivative, and we also know from the chart that if the second derivative is equal to 0 and changing signs, then the first derivative has a relative min or max. And that's going to be what's going to help us here, because we are looking at the first derivative. And so if I look at this graph, I've got a minimum here at x equals 0, a relative maximum there at x equals 2. And so those are the two places where the graph of f is going to have an inflection point. So let's see, I'm going to write my answer over here. The graph of f has inflection points at x equals 0 and x equals 2, because f prime, remember, whenever we're justifying answers in these free response questions, anytime that you write the word because, the very first thing that should follow that word is whatever's given to you in that particular problem. I can't justify my answer using f double prime because I don't have f double prime. I need to justify using f prime. And this is because f prime has a relative min at x equals 0 and a relative max at x equals 2. All right, last part to this question asks us to find an equation for the line tangent to the graph of f at the point 0, 3. Well, when we see equation of a tangent line, you know that I want us to use this formula, y is equal to f of a plus f prime of a times x minus a. And they gave us this point here in the question. That's going to be our a f of a. Anytime you're given a point for the equation of the tangent line, that's your a f of a. So that means that I know y is equal to f of a, which is 3, and my a over here is 0, so I'm going to have x minus 0. So all I have to find on this one is f prime of a, or f prime of 0. And if I remember, I have a graph of f prime, so all I have to do is look at the graph. F prime of 0, that's this point right here. F prime of 0 is negative 2. So that means my slope of my tangent line is negative 2. And on a free response question, I would want you just to stop right there. No need to simplify or anything. Just leave your answer in that form. All right, on the next question, we've got an implicitly defined function, y squared is equal to x cubed, and we want to show that the second derivative is equal to 3x over 4y. So if I'm going to find the second derivative, the first thing I need to do is find the first derivative. So derivative of y squared, 2y dy dx, and the derivative of x cubed would be 3x squared. And then if I solve for dy dx, I'm going to divide both sides by 2y, and I get dy dx is equal to 3x squared over 2y. So that's my first derivative. So now I need to find the second derivative, and I'm going to use the quotient rule. So let's see, I'm going to change colors here. So my second derivative is equal to, I'm going to remember the quotient rule, let's just write it up here for reference. Quotient rule is g f prime minus f g prime over g squared. So g is 2y times f prime, which would be 6x, minus f, which is 3x squared, times g prime, which would be 2 dy dx, and that's all over 2y squared. Now at this point I need to substitute back in what dy dx is. So let's see, I've got 12xy, and this is minus 6x squared times dy dx, which is 3x squared over 2y. And this is all over 4y squared if I square the 2y in the denominator. So I need to get a common denominator in my numerator, which is why I left this space here. I need my denominator to be 2y, so I'm going to multiply this first term by 2y over 2y, and this would be equal to, let's see, 24xy squared over 2y minus 18x to the fourth over 2y, and this is all over 4y squared. So if I multiply by the reciprocal here, this is 4y squared over 1, so times 1 over 4y squared. Then in my denominator here, I've got 2y times 4y squared, which would be 8y cubed, and in the numerator, 24xy squared minus 18x to the fourth. We'll just barely squeeze that in there. So I've got my second derivative probably about as simplified as I can get it right now, but remember that I want to make it look like 3x over 4y. We want to make it look like this, and so I've got to do some substitution here. I remember that y squared is equal to x cubed, and so I've got y squared right here. So I think I'm going to substitute into there x cubed, and notice when I do that I'll end up with x to the fourth, and my other term is also x to the fourth, so that gives me like terms in the numerator, and I'm going to be able to combine them together. And then in the denominator, notice that in my denominator that I'm trying to get, it's just 4y, and right now I have y cubed, so I'm going to think of that y cubed actually as y squared times y. And I'm going to substitute x cubed for that y squared. So now I have 24x times x cubed minus 18x to the fourth over 8 times x cubed times y. And so on the top, I get 24x to the fourth minus 18x to the fourth. That leaves me with 6x to the fourth. And in the denominator, I have 8x cubed times y. So now I've got, I can cancel x cubed and just leave 1x there in the numerator. I can also reduce this 6 over 8 and make it 3 over 4. And I end up with 3x over 4y, which is exactly what we were looking for.